Hi.
Okay. Hello, everybody. Today, PG Stat Monitor, the new way to analyze query performance in PostgreSQL. My name is Ibrar Ahmed, and welcome to your FOSDEM platform. So, I will introduce myself, and then Peter will introduce himself, and then we will continue our slides. So, who am I? My name is Ibrar Ahmed, and I have been in software industry since 1998. And I've been working with PostgreSQL since 2006 and have been in multiple PostgreSQL companies. And nowadays I'm working with Percona since last 2.5 years. I'm also a PhD candidate and PhD scholar, and I'm completing also my PhD. And here it is, the Peter.
Yes, the Peter. Hey, I'm Peter, and I'm helping Ibrar with his presentation. I also happen to be CEO of Percona and database performance geek, right? I mean, I do not know as much about Postgres. I even probably say what Ibrar has forgotten more about Postgres than I will ever know. But I've been involved in the database industry for a long time, and I thought it would be good for me to share some high level of why we are working on this extension and new way of performance monitoring for Postgres. Next slide, Ibrar. Yeah, that is agenda, and I think there is another section of mine. So at Percona, I've been working on the open source database performance problems for now over 15 years, and actually a few years before that in MySQL, AB, and other companies. Now, one thing what I learned in that time is what the modern databases are very, very powerful, right? If you look at Postgres or actually any other modern database, it can take a lot of beating and handle very significant workload if things are done right. But if you can write bad queries, then even few of those can really bring down otherwise very capable database. Now, if you look at that from a user standpoint, they often may not know what they have such queries, right? And then if they do, right, and say, oh, database is slow, probably have a bad query somewhere, they may not know the source of those queries, especially if they're running one database with many users, many developers, many applications. And finally, often it may not be that easy to find what to do with that bad query or queries. Then you spot them, right? And this is the problem what we are looking to solve, and this extension what we're going to talk about is a foundation component of such solution. Next slide. Now, if you think about the query data, there are a couple of approaches how you can source that data, right? And on a high level, you can think either from sampling the data, right? Then you can say, hey, 100 times a second, I'm going to look at the whole state of all my Postgres, see what queries are running, where they're stuck, are they on CPU, waiting on disk, and so on and so forth, right? And get that data. The good thing about that, the overhead is limited, like pretty much by number of processes, right, and a sample rate, but also you have a limited accuracy, and also you can have various measurement artifacts, right? For example, often enough you will have your sampling process to be scheduled on CPU and run only if that CPU is because CPU core become available, and that means it's freed by the query which was running before that, right? So you often tend to see more queries than in a waiting state, right, or completed than the system actually has, right? And those systems can especially measurement artifacts can especially escalate when you have a system getting under extreme load, right? That is frankly, a worst case when you want to have that data. Also, you can have another approach, which you can think about as event counting, right? When a query starts, we increment the counters, how many rows it's processed, some other statistics, and then store that data somewhere or get it out to a log file. And in this case, you are risking of an overhead, which can be quite higher, but you can use can get very good accuracy. And in pgstat monitor, we are using event counting approach, and also as Ibrar will show you, we are able to do that with typically very limited performance overhead. Next slide. Okay. So if you look about the after we source those events, what exactly we can do with them? Like one approach is we can spit them out in the log, right? And then our consumers, like some monitoring application, can parse the logs. And that gets kind of complicated, especially in the cloud, when you, with something like Amazon RDS, you may not have a choice to run, some agents on the database engine itself, right? The other approach is also you can have a database to maintain the same query log of all the queries it runs in some sort of tables. And that typically gets expensive, right? For every, select for a primary key, you actually also have to need to do an insert in some log table, right? That sounds heavy, right? Because it is. And a third approach is to say, well, you know what? We are not going to store information and make obsessive about every single query, but we will capture enough statistics, enough summary to give you the most important information about your workload. Right? And that is a workload pgstat monitor takes. Next slide. Finally, let me highlight some data points about what is we are doing in pgstat monitor and why, and that is important. One thing is what we are going extra mile to make sure you don't have just dollar star parameters, but actual values in the query when possible. Why is that important? Because in this case, you can actually run explain on the query, which you see is running slow, right? And actually, you often can play with query, modify it. Maybe you find a better way to run the same query, but also ensure it has the same results, which is much more complicated if you just have parameters you have to figure out what to replace them with. We also have a time bucketing, which gives us a high fidelity stats with much better network, poor network quality tolerance, right? So this kind of maybe a little bit complicated, but think about this situation. If you have your database system, which is stored somewhere relatively far away with bad quality, you are sampling the data, for example, every 5 seconds. Now, that means you are trying to sample the data every 5 seconds. But because of a network jitter, you may get the data actually which corresponds to 4 seconds sometimes and 6 seconds at the other piece, right? Which will reduce quality of your data. And that makes it harder to separate signal from the noise. Then we are doing the time bucketing inside the system, right? Then that means we are always getting the data on exactly 5 minutes interval, and if there is any change in workload between those, that will be very well visible. We also provide information about the client IP, the source of hosts, which send the query, which is important for security analysis, as well as it helps to spot where workload is running which should not be, right? In so many cases, I see, well, where the hell is this query comes from? It comes from an old version of applications, which we should have already decommissioned long time ago, which can be hard to find. While if you have a client IP, that gives us gets us a good answer. We also capture failed queries, right? These are queries which never completed, but I think they're still important because in many cases the query may be failing actually because it runs for a long time, right? Let's say it has been waiting for lock for a very long time, and then it failed after waiting for 20 seconds. Well, you probably want to use that, know that, because that impacted the system and impacted the end user. We also capture relations, which query touches, right? Which is wonderful because it can easily spot all the queries which touch given relations, right? And you will say, well, but can I just parse the query manually? Well, that is not a good idea, and it's not going to cover all cases. Think about stored procedures, think about use. You cannot, in this case, extract relations by just parsing the query. And finally, I want to highlight response time distribution, right? Because just getting the average query execution time doesn't give you a lot of information. In many cases, you can get a lot of insights to understand how the query response time distribution looks like, as well as your users don't care about average query response time, right? They typically care what their queries do not run slow, right? And that is much better understood with histogram. Next slide. Well, that was my little intro section. And now, Ibrar, it's back to you.
Yeah. So welcome again. And here are some statistics and monitoring tool. I just rated some of the 3 or 4 here in this slide. So one, the main and the basic one is the pgstat statement, which is the part of the PostgreSQL code distribution. So we take that pgstat statement as a base and edit all of the feature in that to enhance and make a new monitoring tool for the PostgreSQL. So which is called pgstat monitor. It's called PostgreSQL query performance monitoring tool. So it's a new tool based on pgstat statements. It has almost every feature of pgstat statements and have many more other than the pgstat statement. So here is the brief summary of that. So which feature pgstat monitor has, column has, and pgstat statement does not have that. So like a bucket concept, pgstat statement does not have a bucket concept. I will let you know what is exactly the buckets. Peter already explained you a bit about the buckets and time buckets and the client IP. Pgstat statement does not show you the client IP, and pgstat monitor has that. Similarly, the application names, the relation, the commands, the error code, the error messages, the SQL code. These are all the feature pgstat monitor has, but pgstat statement doesn't have that features. It's not the only feature pgstat monitor has. It has many more. It's just a brief summary of pgstat monitor. So pgstat monitor is a standard PostgreSQL extension. When I'm talking about a standard PostgreSQL extension, then all the method to download, to install, and to configure is the same as all the PostgreSQL extension. So it's truly open source. You can go to the GitHub page, you can download the code, you can download the releases, and then you can compile it and you can use it. If you don't want to compile it, just download it, the Debian package or the RPM package for Percona site, Percona repositories, and you can use that. And one more thing, I'm also 2 or 3 days ago, I also released that on pgxn, and you can also install pgstat monitor using pgxn. So just pgxn install and pgstat monitor. Install the latest version of pgstat monitor on your machine. So when you install that, then you have to configure it. I already told you that it's a standard PostgreSQL extension and almost follow the same steps to install the pgstat statement, but you have to change the name. Instead of pgstat statement, you have to use pgstat monitor. So in the postgresql.conf file, you have to change the shared preload libraries to install that. Or you can use alter system command. Don't forget to reboot that. You have to reboot before using this extension. And when you reboot that system, it will start collecting the information, regardless you have created that extension or not. If you want to use that extension, you want to get the statistics and monitoring information from that, then you have to create that extension. Then you will be able to extract that information from PostgreSQL. So there are two version concept here. So why I have mentioned here, because don't let you confuse. The one is the SQL version, which is the extension version, and usually it is 1.0. And when we have a very drastic change in PostgreSQL extension SQL file, then this version is changed. And mostly this version won't change because we don't usually change too much thing in pgstat-monitor or extension SQL file. And there is a build version, and this is the actual version of pgstat-monitor. We have already provided a function for that to check which version you have installed, which is pgstat-monitor version. You can check that which version you have. And don't confuse the SQL version, which is 1.0, it's SQL version, and the build version, which is a 0.7.2, because it's not in the GA. So it's not 1.0, it will be soon 1.0. So for looking at there are some setting we have provided for pgstat-monitor, because we have to configure pgstat-monitor. It has many configuration, GUC variables. So I have created a view for that select static from pgstat-monitor setting, where you can see the name of the variable and the value, current value, the default value, the description, the minimum value, the maximum value, and the restart of PostgreSQL is required or not. So it will give you the insight of in a one view. So in this slide, pgsm max, they set the maximum number of statements tracked by the pgstat-monitor. So you can configure that. The value is 5,000, default is 5,000, and the description, you can see the description here, and the minimum is the 5,000, and the maximum is some number, and the restart, yes, the restart is required. If you change that variable, you have to restart the PostgreSQL. So query monitoring, you can monitor the query, and there is a two-way to monitor your query in pgstat-monitor. So one thing is you just write, which is the default, set pgstat-monitor pgsm, which is a pgstat-monitor normalized query is equal to true, and you just query select a from foo where a is equal to 10. And when you query pgstat-monitor, and you can see that you have a placeholder instead of 10, where a is equal to $1. $1 is a placeholder. So PostgreSQL change 10 and put that $1 here. But sometimes when you see that your queries are not running very fast and you want to see the actual values, pgstat-monitor statement doesn't provide that. So pgstat-monitor provides you a facility that if you set that configuration parameter, pgstat-monitor normalized query is equal to false, and then you execute that query, then it will show the exact value, which is 10, a is equal to 10 instead of the placeholder. So now you can copy this command and you can run that command, and you can see what's happening there and which value is taking a longer time. So now you have a facility to see the placeholder, or you can see the actual values. So now the time bucketing. So what is the time bucketing? Time bucketing is we have divided a whole monitoring information into multiple buckets. It's configurable. So right now I have configured it to 5 buckets. So if you can see in the right side, we have a bucket 0, bucket 1, bucket 2, bucket 3, and bucket 4. So we store the bucket start time, and we have a bucket time. So like if we have a bucket time here is 9:30, and we have a 30-second bucket. If we have a 30-second bucket, we have 1 minute. almost 1 minute bucket. So you can see that at 9:30, the 0 bucket, and 9:30, 30-second bucket. And after 30 seconds, we have a second bucket, and we aggregate the information within the buckets. And when one bucket is failed, that time is over for the one bucket, then the second bucket will be started. Then the third bucket, then fourth, and then the 0 bucket will be override. So it will recycle the buckets. So you have the time to collect the information from the bucket till you have all the buckets before the recycling of the first bucket. So you have to configure the total time of the bucket and number of buckets. It's in your control. You can configure that. So how much time you want to give to the one bucket, and how big is how many buckets you want to have. So other than query logging, you have to monitor some of the queries which has some errors. So sometimes you don't want to monitor all the queries which are running successfully. Sometimes it's happened that your query is failing continuously. So you have to see which query is failing continuously and what is the error. So here is some information available. So you have a level which can be error, warning, info, whatever it is, and then SQL code, then the actual query, like here is a select static from pgfoo, and pgfoo table does not exist. So it's giving you the error, relation pgfoo does not exist. And then the second query, the select 1 divided by 0, and it's obvious error that it's a divided by 0 error, and it's showing you that it's division by 0. So you can see, and you can also count that how many times this error occurs. If you just also query the calls, so you can see how many times this error occurs. So you can see this error is 100 times this error is occurring. That means you have to fix that one error is occurring 100 times or 1,000 times. So you can fix that problem. So as Peter already explained, that there is a very good information available, which is object name extraction. If I am saying object, not the table, because we can extract the information about the views and the table containing in that, using in that views also. So like here, select static from bar, I'm just querying a table bar. So it's just showing the table bar is used. So second one, I'm just querying foo comma bar. So you can see the two tables you can see here. Suppose you have a view, which is name is just a view, and you want to query that view. So it will not only extract the name of the view, but also it will extract the actual table used in that view. So then you can check that this query touches how many tables. So you can configure your query much better than that. You can rewrite your query if you feel some problem in that. So you have a very clear picture how many tables are being touched by your queries and how much time it is taking. So that is really useful information for you. So the query histogram. What is a query histogram? The query histogram, like if you want to query and you want to see how many times your query is running between less than 1 millisecond. So sometimes you want to see that how many times your query has run in less than 1 millisecond, and how many times your query runs 1 millisecond and 2 millisecond, like in 2 millisecond and 3 millisecond, and greater than 3 millisecond. It can be configured. So you can configure how many these buckets you want and how long it is. Like here, I have only 3 or 4, less than 1, less than 1, 1 or 2, 2 and 3, and greater than 3. It's just 4. So you can configure how many you want to have, and I have that in 1 millisecond bucket. So it is counting that this query select static from PG bench accounts runs 5 times less than 1 millisecond. Okay, from 0 to 1 millisecond, it runs 5 times. And this query runs 1 millisecond to 2 milliseconds 2 times. And this query runs 9 times and taking more than 3 milliseconds. So it's just showing you that 5 and this query is running how many times. You have a total of 16, but you want to see your queries, how many times this query runs in which bucket, in 1 millisecond, 2 millisecond, 3, or taking more than 3 milliseconds. So you have a clear idea on that. So like here, you have a different option here. So I'm just planning to write some queries here. Like this is just an example to elaborate that how query timing histogram will work actually. I will provide a histogram, and just in the future version, you can see a function histogram where you can provide the query ID here, and you can provide the minimum value and maximum value of that, and how many so you have to configure that how many histogram buckets you want to have. So it will show you the bucket, it will show you the range, and then the frequency of that query, and then it will show you the frequency here the 5 times it runs 0 to 1 millisecond, then it have a 5 static here, and run 3 static here. If you see 2 to 3, it's 10 static, and it has 5 to 6, that means 500 times. So we can't have a 500 statics here. We have a hash, which is 1 is equivalent to 100, and then we have multiplied it by 5, then it's 500. And we have 1,000. 1,000 mean we have a dollar sign, which is equivalent to the 1,000. Then it's just a query. You can configure it. But what we will provide you for that, we provide you the histogram function. So in the next version, you will see that how you can see that information. Information is already in pgstat monitor. This is the view how you can see that information. So we have to provide a better view to analyze and view your query. So planning statistics, a PostgreSQL 13, a pgstat provides a new feature in PostgreSQL 13, which is a planning statistics. So now you can have a planning statistics. So pgstat monitor inherit that feature. If you have a PostgreSQL 13 version and you have a pgstat monitor installed on Postgres 13, then you can see a plans variable. So how many times this plan, and you can see how many times it's how many queries can be plan 100 and 100, and then insert into it will call 100 times. So it will call 100 times and plan 100 times. And you can see the copy pgben, it was not planned, it's 0, and it was calls 2 times. And you can see last query, it is planned 10 times, and you can see the calls are 10 times. It calls 10 times. So here are some more variables. You can see the columns. We have the information like CPU user time, CPU sys time, some other variable that we have, and it is not the part of the pgstat statement, but we have a pgstat monitor. So it is just a view, sorry. And here is our performance statistics. So I benchmark a system with a 64 core machine and have a lot of memory there. So I just try to benchmark that. It is not complete detailed benchmark, but I have some like 1.6 GB, 16 GB, and 160 GB database, and just I got a TPS of, and you can see vanilla PostgreSQL, which does not have pgstat statement and don't have pgstat monitor, and I install pgstat statement and collect that information, and you can see a minor slightly performance degradation, very slightly. And when install pgstat monitor, you can see it's almost the same thing. almost the same performance we are getting. Even in some cases, it is better than pgstat statement, because there is a one more major advantage that we are not touching the disk initially. pgstat statement stores the actual queries onto the disk. So pgstat statement store actual query onto the disk and get that query from the disk. But in pgstat monitor, we are storing the query in the shared memory. And if that shared memory is not enough for that, and then it will hit the disk. So if you configure your shared memory properly, then you won't hit the disk. So you can have a better performance from that. So it's up to you how big your machine is, how do you configure your machine, so you can get a better performance from that. So PMM is a Percona management and monitoring tool, and pgstat monitor is integrated with that. So you can have that information and you can integrate that and you can use that with PMM. It is already integrated and you can download it and you can use it. So feedback, if you want to provide the feedback, we have a Jira project for that Jira Percona.com projects PG issues. Just go there and log your issue. If you have found some issue, just log the issue. If you have some feature request, just go there and have a feature request from there. And if you are a developer, if you want to contribute in that, just create a pull request, work on that and pull request. We will happy to review that and integrate into the pgstat monitor. So thank you. That's all from my side. Peter.
Yes, well, thank you, Ibrar. That was very good talk, but you know it already. And thank you everyone for attending, and we'll be happy to answer questions.
Yep. Thank you.
Yeah. Let us know when start.
Yeah, I'll give you a shout and then join you. So we're live.
Okay. Now we have some time to answer your questions.
Yes, thank you very much for that talk, Peter and Ibrar. It was quite interesting and a lot of questions, as we could see on the chat. Unfortunately, Ibrar, we might have some issues talking because he got tired about all this discussion before. But I guess that you are going to be able to speak for him because you've been working together for this project very closely. So one of the questions that came kind of a little bit more was about the similarities and extension from pgstat statement. And the question is, what are the real difference in terms of code? And why not have this as an extension of pgstat statements? So if you can elaborate on why the differences and why two different projects, that would be useful.
Yes, of course. So when we embarked on this project, right, we really wanted to see what we can do without caring about the comparability in terms of data formats, right, or approaches with anything existing. So we took pgstat statement as a baseline, but as you would, or you saw from presentation, pgstat statements use a different data model, right? It has this sort of a time-based bucketing instead of one global summary, right? So if you would just replace it, then the applications which have been relying on pgstat statements for years will break, right? And now our intent in this case, as we experiment with different approaches, right, and get more to their to the GA release, we will obviously seek some more community buy-in, and if that is something which will become the next version of pgstat statements, we would be very happy with that, right? That doesn't have to be as a separate project, but that is not our choice to make it like this.
Yeah, correct. And also it allows you to explore a little bit further what are the possibilities and things like that. If you look at other projects like pgLogical that also put everything back to the core system, pgLogical could explore more, and then the logical replication that's going in the core system is different. So I think it's kind of valid way of doing the collaboration between the two communities. There are some more specific questions. Nick, he was asking about the IP that is stored on the table.
I was wondering. So the extension itself looks very, very promising. Good work, kudos. But I did not see a slide showing the storage of the IP addresses with the statement that you mentioned initially. So I was just wondering, how are they stored, and can you disable that? Because IP addresses are considered personal data, at least in my jurisdiction. So it is always a little bit tricky to store these alongside with other information. So can you just disable that in case you want to? Otherwise, it would be a feature request.
I think at large extent that should not be a problem, right? I know what we are already doing that for query parameters, right? Because some folks really like having sort of like a query examples, which you can sort of copy directly your console or run explain for. I can say, oh my gosh, I may have like a credit card numbers out there as a query parameters, and I don't want seeing those, right? So we had that. There should not be a problem to essentially have their option to neuter that, right? And to replace it with a null value or something. So I wouldn't. So it's not there, but it shouldn't be a problem. Another thing to consider is in many environments, right? You may see the load balancer IP out there instead of your user IP. All right, so that's right. Well, and that is kind of a third one, right? And speaking about IP, right? I have that in your case. Typically, you are speaking about IP, which is not of a kind of an end user, which you would be concerned about, right? But in many cases, that would be your application, which you run inside your environment. So it's kind of your IP, typically kind of private, right? And which should not be kind of subject to this concern.
Yep. Okay. Yeah.
But for some use cases, I think the ability to collapse those kind of and not store IP would be helpful.
Mm-hmm. Thanks a lot.
Yes, thank you, Nick. So we were also looking at the chat. Several questions involving the histograms, more like questions like comments, like the histograms are really nice stuff. All this packet is really something very useful. And also the integration with the PMM tool that was shown at the very last. Is PMM tool also open source, also available?
Yes. Yes, PMM is also open source.
Right. And you can use it in regular Postgres. You don't have to have the Percona
distribution. Absolutely. No, yes. Yeah, you can use it with standard Postgres. You don't have to run other Percona stuff. You can just use PMM features.
Right. Another question about, I don't know whether this is an interesting question or not. Windows support. Any plans for Windows support?
Well, I think that is a good question, especially in the open source project, right? Frankly, as Percona, we do not focus on Windows with our software, right? And I don't see that as being priority for us for pg.monitor, but we very much would love if somebody would want to, submit a patch, right, whatever is needed to validate that it builds on Windows. We would love to see more contributors.
Right. Okay. There was also a question about whether it's or not available of pgxn.org or whether it's going to become available. I know you answered this already in the chat. But
yes, it's already available.
It's already available. Yeah. Good. Excellent. Well, this is FOSDEM, so we can always discuss things that are more about the development and also about the discussions and how every software have to make progress. And one of the questions is, about making this as a contribution to the Postgres community, because now you have the freedom of doing whatever you want with pg.stat_monitor. If you make it kind of part of the Postgres community, you have to get involved in all the discussions and the mailing list in order to make this not your own project, but the project of the community. Have you already have some interactions in that? Do you have any experience, or that will be something to discover for your team?
Well, their lead on this project at Percona is Ibrar, right? And Ibrar spent more than decades in PostgreSQL community, right, for the number of companies, right, and have been involved in a number of foreign data wrappers before this project, right? And it's kind of, unfortunately, he cannot speak for himself to answer this question, right? But that is what Ibrar is handling. I know they already have reached out to a number of people, had feedback. There are already a number of folks from other companies who start to contribute to this project, right? And it is So we are working on this and looking to work it even better. Excellent. Right. I think one thing in this case, and this is kind of what I kind of put in my CEO hat on, right, if you will, what I told our group, we have kind of two different goals in this case, right? Obviously, we have a Percona distribution for Postgres. We obviously have a PMM, right? And we invest in this project, right? So it works out with PMM and it has our Percona distribution for Postgres more awesome. But at the same time, pg.stat_monitor on itself is their community project, right? We are looking to serve the needs of their PostgreSQL community overall outside of what Percona interest is, right? And that goes both in terms of what we are doing, right? Like making it available for other means, and what features we are going to either build or accept as a contributions, right? It's should not be just serving Percona needs.
Right, exactly. And it's not just that pg.stat_monitor should contribute to pg.stat_statement, but it's also that people from the community can contribute to pg.stat_monitor on its own as a different project. Because
absolutely, right. And that is the main point, at least at this stage. Because as I mentioned before, right, what we want to look and see how far we can take that, right, and what we can build if we are not limited to any of their previous working conventions. And we really look at a lot of extensions, right? pg-sanitel, right? Like Ibrar mentioned all of them, right, in the list, right? To see how we can borrow all of that stat and really see how you can connect those things to their sort of like a per query view, right? Like kind of some uniform view out there. That is a goal of a project.
Excellent. Good. Thank you very much. Nick, do you have anything else to add?
Right now, I'm busy chatting with Simon. I think he has a question and tries to get into our room. I'm not sure, though.
I asked Simon questions just a few minutes ago. So I think if you have another question from him, that would be useful as well.
Let's see.
Otherwise, for the people who were willing to listen to Ibrar during the question and answers section but could not, we have an interview with Peter and Ibrar that we are going to publish this weekend or maybe tomorrow, where we talk not only about this talk but also about other stuff. This is going to be very interesting. It's a short interview, so it's not going to take you much time to review that. And then you can hear Ibrar live again in an interview. Okay, so if there are any other questions, you can always join this room after the time slot associated for this talk. Then at that moment, there's going to be a link appearing on the chat of the Postgres Dev Room, and then you can join this room. And Peter and Ibrar are going to stay here, I guess, for in case that somebody wants to discuss things with Peter and Ibrar, maybe not just about the functionality of pg.stat_monitor, but also in the way of how to contribute to the project. That will be interesting. So the link is going to be public in 15 minutes. So you can see the link And you can join this room and then chat with them.
Probably more than 14.5, yeah. But
14.5, yeah, exactly. Nick is known for his accuracy.
I love you too, Boris. But I don't know if people are interested in watching us drink coffee and yeah, I don't know. So, but of course we'd fancy if the speakers would hang out here, and because later people are also able to join this video conference, so you can have a face-to-face chat. Not with Ibrar, though, not today. But in general, that would be a nice option.
Yes.
To see somebody.
We have another question on the chat at the moment. It says, well, first of all, Simon says, thank you to you guys for the talk. It says, Dave Pitt says, how about weight event analysis? There's a good one. The weight events is not that obvious to monitor, I guess, but how about weight event analysis? Was the query slow because of high CPU time or IO time or blocking lock weights?
Yes, yeah. Well, that is a great question, right? And that is something we are researching how to get that right with best with reasonable overhead, right? If you look at what we see in other extensions are doing, right? A lot of weight analysis are done with sort of sampling right now, when you can, and that works well if you're looking at overall system, and you can say, oh, the system overall spends so much time on IO weight, spends so much time on, waiting on rollover logs, right, and whatever it is, right? If you're looking at their per query basics, right, to map those weight events to specific queries, how they contribute time and how much response time, that is more technically challenging, right? And that is, I know Ibrar is something working on, and if you have some ideas about how to approach this problem, we would love to hear your feedback. Or maybe even a patch, everybody in open source, right, loves that.
Yeah, Ibrar mentioned that it's in the plan. I mean, it's just probably waiting that it's coming, or but having ideas about how to implement it, I think is important, because it's not an obvious thing to do it, especially for the overhead that it can produce. Good. So I think we have just to wait for people to join here on the chat on text, and for the rest, I think we can stop with the video broadcast. So I thank Peter and Ibrar once again. Thank you also, Nick, for co-hosting. It's always good to have you there. So
yeah, thank you. Yeah, and I want to also to say thanks to Simon, right, for changing the question of that is not our choice, and obviously as the time goes, we want to get more discussion started. I also believe it's good to have those discussions when you have something kind of meaningful to show, right, and to play with, right, beyond just we have an idea to do X, but that is something we surely can and should do more and better. Good.
And with that, just more positive feedback on the chat. People being thankful for the presentation. So I think it's very appreciated. Thank you, guys. Bye. Cheers.
Thanks.
Bye.
Bye.
Thanks. Bye.
Peter, I believe that you're very busy chatting with the other people. So you are still live, you're still being broadcasted. So if you want to turn off your camera, feel free to disconnect from the call. Peter, if you want to disconnect from the call, you're okay because you're still being broadcasted. So.
Okay.
Yeah.
That's right.
That's okay. Fine.
Okay.
Okay. Cheers.